Okay, guys, today we are going to do a real quick mini lesson on scientific notation. All right. So if you're looking at the screen, we're going to talk about how to go from scientific notation to standard notation. We're going to talk about how to go from standard notation back to scientific. And then we're going to have a little check for understanding. Okay. So let me go ahead and get my journal out here. I'm going to show you my notes that I've taken. Now, guys, you don't have to necessarily get this written down. If you're my kids, I would suggest you write this down in your journal, okay? So scientific notation is what we're talking about. And let me just cover up some stuff so we're just looking at a few things. Guys, scientific notation is just a way to write really big numbers or really small numbers that have a lot of digits, okay? Even small numbers like decimals could be 0.00000000009. So that's a way of writing them without having all those digits, just like with real big numbers, okay? This is an example of scientific notation. 5.26 times 10 to the fourth. Here is my power. This whole entire thing is called a power, okay? 10 to the fourth power. The exponent is the 4. That exponent's really important to us, okay? Now look at the main number that we've got, 5.26. Keep this in mind always. If you're writing in scientific notation, guys, it's only correct if you only have one digit, and that digit cannot be 0. You have to have one digit that's in front of the decimal point. Notice the 5 is the only digit. It can't be 0 in front of the decimal point. And what I did is I wrote some good examples and some bad examples down. Look at my good examples. 6.6 times 10 to the third. Again, one digit in front. 1.71 times 10 to the negative second. Again, one digit in front. Did you guys notice that power is negative? We'll talk about it. Or the exponent. 3 times 10 to the fourth. Now, somebody's going to say, that's not right. I don't see a decimal point. Well, if this is a whole number, which is 3, the decimal point is actually there, isn't it? So technically that's still correct. There's only one digit that's a non-zero in front. Look at my bad examples. 98.1 times 10 to the fourth. Hey, that's not correct. There's 2 numbers in front. No, that's not a good example. 0.61 times 10 to the negative third. There's nothing there. Nothing there. Technically, it's a 0. No good. And then 915. I don't see the decimal. Oh, it's a whole number. It goes at the end. That's got 3 digits in front. Bad examples, okay? Real quick. Now, look here. I'm going to work 2 examples with you going from scientific notation, like these are written, and we're going to rewrite these numbers in standard. This is the easy part. When I told you before that the exponent is the main part that you look at, this is really important. The only thing you guys have to do when you're doing this is you're going to move your decimal point either right or left. And it is the number of times that that exponent says. Now, the key is sometimes your exponents are negative, sometimes they're positive. So you have to determine, am I going to move the decimal point right or left? Well, let's talk about this one. I want everybody, if you get a chance, write down 6.34 or just pay attention. I'm sorry. If I am going to move my decimal point according to this, that tells me how many places. I'm going to move it 2 places. Am I going to go right or left? If it's a positive exponent, you move it right. Because think about it. If I'm multiplying by a positive, we're going to make the number bigger. When I think of multiplying by positives, I think it's going to make it bigger. It gets bigger by moving right. So 2 places, look, 1, 2. And I put my new decimal point there, and there's my final answer, okay? Easy, isn't it? Now watch what happens when you've got this one, 7.2 times 10 to the negative third. Now, if it's a negative exponent, you move the decimal point left. Okay, so I'm going to bring down my 7.2. And we said we got to move it 3 places, but because it's negative, I'm going to go 1, 2, 3 places to the left. Do you notice how I'm doing my little squiggly marks, my little loop-de-loops, whatever you call them? That helps me figure out what goes where. Because look, if I do my loop-des, I've got blank spots here, but I put a 0 in that little blank valley, that little loop part. And there's another 0 that goes there. So my answer is 0.0072. Now I want to show you something. Sometimes your answer choices are going to have a 0 in front of it. Did not change anything. The value is still the same, okay? So that's how you go from scientific to standard. Let me real quick show you how to go from standard to scientific. First thing we always do is locate where the decimal point is, all right? Now, that's a comma. That's not the decimal. This is 3,190. And if you don't see it, that means it's whole, and that means it goes there. Now, remember earlier we said when you write it in scientific notation, it has to be one number only. That's not 0, that's in front. Well, where do I want it to go? I have to have one digit in front. There's my first digit I see that's not 0, so I'm going to move it to there. Well, let's count what we did. 1, 2, and 3. So I moved 3 places. Well, let's go ahead and write this out. So write your new number, and put your arrow there, 3.19. I don't need my 0. It doesn't matter. Times 10. And we said we moved it 1, 2, 3 places. Now, the biggest mistake kids make is determining whether this is positive or negative. So here's how I want you to always look at it. We understood up here that if I multiplied by a positive exponent, it would make my number bigger, so it would go to the right. So 6.34 times 10 to the second made a bigger number, right? Well, look down here. Let's check to make sure we should have this as positive. If I multiply 3.19 times a positive exponent, that should make bigger than 3.19. And that was 3,000, so that was bigger. So this is correct. It is a positive, okay? Now let's look at this one. This one right here, there's my decimal point. Now I have to have one digit in front of the decimal point. So I'm gonna go look for my first digit that's not 0. There it is. And I wanna have him in front. So I'm gonna move my decimal point here so I can have 1 in front. Let's count. 1, 2, 3. Oh, again, it's a 3, huh? I don't need these zeros, so I'm going to write what I see here. So 1.2. Now, we said we moved it 3 places, but here you got to check to see if it's positive or negative. Now, look, again, if we multiply 1.2 times a positive, that should make him get bigger than 1.2. But this original number was a lot smaller than 1.2, which means this should be a negative. Again, let's check it again. If I multiply 1.2 times a negative, that should make him get smaller than 1.2, and that guy was a lot smaller. There's your examples. Here's your check for understanding, guys. I want you to solve these 2 problems. Number 1, I want you to write this out in standard form, so you're going to move your decimal point. And then this one, I want you to write this guy in scientific notation. So you're going to have to move the decimal point again, but put it in the right spot. Hey, good luck. Hope you guys got this. Talk to y'all later.